Monday morning, everybody. Mr. Surdui here, back again on a rainy Monday with some AP Stats videos for you guys. So these are going to look at Chapter 1. Now we're going to look at quantitative data. So these series of videos will look at how we analyze quantitative data, how we describe that data using numbers, because now we actually get to work with some real numbers, and also how we would show that information in graphs. So I'm going to hop over to the board and we'll get started with this. All right, so as we're going to begin our discussion here with describing quantitative data as graphs, we want to remember that now we're looking is at numerical information. So much different from looking at categorical data where there really wasn't a way to kind of put them in any sort of order because they were because they were things like colors or favorite state, things of that nature. Now with numerical data, we kind of have this inherent way of being able to put stuff in order. So the two types of graphs we're going to look at in this video are going to be the stem and leaf plot and the dot plot. So again, for some of you, you might be already familiar with these two, but I want to talk about how we construct them and so forth. So as an example I took here was this collection of data from the textbook. This is actually from the very beginning of the chapter, which was the number of goals I believe that were scored over the course of different World Cups. So this is the data that we get. Now, typically, this is how data usually will look like. It's not in any order. It's not nicely put, into categories for us. We have to sort it out. So with a dot plot, so a dot plot is us drawing a number line. Okay. And I'm going to label this number line. So I would say, so this data here represents its number of. So I'm going to do the same thing. So number of goal. So I'm going to scale it, and I need to make sure that I indicate clearly how I'm doing my scale. So I'm skipping every 2. Like so. And this is going to go all the way up. I see I have a high number of 14. So what I'm going to do to just expedite this is I'm going to go scales of 2. So 2, 4, 6, 8, 10, 12, 14. I'll stop here. We don't have a 16, but I'm just... Okay. And 0. So now I'm going to go through. So I do see, and I'm going to kind of scratch them off as I put them down. So for 1, oh, sorry, I do have a 0. So 0, I'm going to put a dot for that 0. There's 1, 0. Then for 1, I have 1, 2, 3, 4 1s. So 4 1s. So over here, I'm going to put 1, 2, 3, 4 1s. So when I have the number repeat multiple times, I'm putting the dot over and over it on top of that same value. Now I want to have them spaced equally. So however close these 4 are spaced, if there are multiple 2s, I want to keep the spacing the same. So you want to, if anything, envision this kind of like a big grid, like I have here behind me, and kind of just put a dot in each boxes. I was aiming for the line, so that's why I did it that way. So the key thing to remember is when you're making the graphs is just keep it consistent. So now when I get to 2s, so 1, 2, 3, 4, 5, and that's it. So there were 5 2s. Now I get to the 2s. 1, 2, 3, 4, 5 2. And I would keep going like this as I fill up the entire grid. So I'm going to take a little time jump here. So I'll see you in a second with the graph filled in. All right. So now we can see that the entire dot plot has been finished. So looking at my plot here, you can kind of see this looks kind of like if we did a bar graph, right? Only there's no bars, it's just dots. And the dots, again, indicate is the frequency or the number of times that that particular value appeared. So this would be a acceptable dot plot to look at. So the reason I can now want to, or I would like to make this, is because now I can kind of see there's this kind of shape to the data. Just staring at the raw numbers before, I really couldn't see really what numbers were more predominant. I see that for the most part, a lot of the most scored amount was 4, and these high numbers are an actual rarity, what we would call an outlier. So it's not like there's all these scorings and 14 is a common occurrence. It's really not. It's actually not very common to see anything. We see a really fast drop from after scoring 4. Only one time was did a game score a 5, and then these super rare games all the way out here. So by putting these data sets into graphs, we're able to it's able to help us in terms of describing a data set, describing what we're going to later call distributions of the data. So this is a dot plot. Now for a stem and leaf plot, it's the same, but now instead of using dots, we're going to use numbers. And the way a stem and leaf plot works is we're going to pick a number to act as our stem. So let's say I do see, again, I had all my numbers all the way to, and I'll erase this to clear it up. I had my numbers all the way up to like a 14. So I could make a stem where it's 1, 2, 3, 5, 6, 7, and I'll down because I'm running out of space. 8, 9, 10, 11, 12, 13, 14. Okay. So it kind of looks like our number line, like our dot plot up above, only I'm running it vertical. Now, when we do a stem and leaf plot, that first digit is our stem, the following digit would be a leaf. So setting it up like this would not be of particular help to me because, yeah, there's a bunch of ones, but I cannot write 1, 1, 1, 1, 1 like this because this would be interpreted. So if I wrote this, this is interpreted as an 11 because this is the stem and this number dangling over here is the leaf. So when we do make a stem and leaf plot, I want to see, since I do have 2 digits, then these singleton digits have a beginning of 0. Now, if I were to just do 0 and 1, let's say that's my stem, all of the single digits would fall under this row right here, which is going to be the majority of my data set. So I would be sitting here writing, okay, it's 0, 0, because I did have a 0, and then 1, 1, 1, 1, 2, 3, 4. Sorry, another 1 I got to add here. And actually, I'm going to use my dot plot to kind of help me draw this a little faster. Then we got the 2s, so then I will be writing 2, 2, 2, 2, 2. Then the 3s, 3, 3. Then the 4s, of which there were 7 of them. So I'm just going to kind of just quickly go through this. So then the last number would be not 5. There'd be other 4s in here. Then we would finally get to the double digit ones, which there was a 13 and a 14. So you see how I write how many double digit ones are there where the first digit is a 1. There's 2 of them. One is a 13 and one is a 14. So this would be a stem and leaf plot. But the problem is this really isn't giving me kind of as much insight as this one is because most of the data is crammed into this first grouping. So I'm not, again, getting that description from looking at it like this. Now, the neat thing about stem and leaf plots is we can decide the category. So instead of just doing a 0 and a 1, since I do see I have so many single digit numbers in comparison to this double digit one, I could set up that my stems will split. So here's what I would do. So I'm gonna do is I could say 0 and 0 star, and then 1 and 1 star. Whatever we set up, again, I want to make sure I'm consistent. So on the bottom here, I'm going to indicate that a star is numbers 5 and up. So this 0 would be looking at single digits, but from 0 up to 4. So I would be writing my 0, my 4 ones, and then my 5 twos, 4, 5, and then we have my 5 threes, 1, 2, 3, 4, 5, and then our 7 fours, 1, 2, 3, 4, 5, 6, 7. But then that 5 would not go here, it would go here. Then the 1, remember this is 5 and up, so that means the 13 and the 14 go here. Okay. So even doing it like this, where I did a 5 and up split, so instead of just having it all together in one group, I split it in half. I still am not, so this is giving me a little bit more insight. I do see that kind of like same little lopsidedness like I did in the dot plot. So you can kind of see the stem and leaf is kind of like a, if you rotate your head sideways, you can kind of see that this is that same kind of dot plot over here. Again, it's not as much detail because everything's getting crammed in this first block. So seeing how the data is panning out, I may decide to split this up still differently. So instead of doing 2 separate groups, I might decide to say, you know what, let's make 4 separate groups or 5 separate groups between 0 and 10. So like I had divvied it up here to get some more detail. So this is where a very important thing about when you're making graphs, scaling, things that you want to consider. So scaling is very important because if I make the scale too simple, like if, let's say I go back to this dot plot and I go 0, 5, 10, 15, 20, then you see all the dots crammed together because you're so zoomed out. Versus if I super zoom in, where I literally sat here and I was doing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way down, then that would give me a much closer view of the data. But this is where you kind of have to play around with the scaling because of the fact that if we're too far away, if we make the scale too big, then everything gets mushed together into a single column like this. But if we zoom in too close, then I won't see a pattern because everything, it's going to look just like coming back to this, where they're all scattered away from each other and we're so close to the data that we really can't see an emerging image or a pattern to the distribution.